Given the generally poor rates of lie detection accuracy shown by people and also by some law enforcement groups, can we turn to machines to help us improve our accuracy? When most people think of lie detecting machines, they probably think of the polygraph, which is also sometimes simply called a lie detector. You've probably seen a polygraph in various movies like Meet the Parents and on various TV shows. The polygraph is a machine that simultaneously records a number of physiological responses from sensors placed on the body. The name polygraph actually means exactly this. Poly meaning many and grapho means to write. The polygraph output can be displayed either on paper or on a screen. That output can show galvanic skin response, which is an indirect way of measuring sweating, blood pressure, heart rate and respiration, which is breathing. The assumption is that lying is accompanied by identifiable and predictable physiological activity in the liar's body. This is actually a pretty old assumption. Quite some time ago, Chinese investigators used to force suspected liars to fill their cheeks with rice powder. If the powder remained dry, the person was identified as a liar. So when is the polygraph actually used? It's been used for criminal and forensic investigations in a number of countries, such as Canada, Israel, Japan, South Korea, Mexico, Pakistan, the Philippines, Taiwan, Thailand, and the United States of America. There have also been some trials of the polygraph in the United Kingdom. The use of a variation of the lie detector test based only on voice was actually recently abandoned in the United Kingdom in 2010 due to low levels of reliability. The UK government had hoped that the test would allow people who were cheating the social welfare system to be identified when they called benefit officers. They are, however, used in prisons. There has also been some use for employment screening, although this is limited in the United States of America by the Polygraph Protection Act of 1988. Their use in courts is also somewhat restricted, as polygraphs aren't accepted as evidence in many jurisdictions. So how do they work, and perhaps more importantly, do they work? Well, there are actually different ways of using a polygraph. The most commonly used and also the most commonly disputed test is the control question test. This test compares responses to deception-relevant questions with responses to control questions. Generally, there might be 10 of these questions all up. The relevant questions might be specific questions about a crime. For example,
on May 17, did you stab Frank Redmond?
Control questions refer to acts that are related to the crime but do not actually refer to the crime in question. These will be more general, vague, and cover long periods of time. The idea with these questions is to embarrass the suspect so that they are forced to lie. This has the effect of increasing their physiological arousal. For example, you might ask a suspect,
have you ever tried to hurt someone to get revenge?
The suspect will be told that answering yes to this question will lead the investigator to assume that they are the type of person who would commit the crime in question. So how does this test tell us whether someone is lying or not? Well, it makes two assumptions. The first is that an innocent suspect will show higher levels of arousal for control questions compared to relevant questions. This is because they have to respond deceptively to the control questions, but they respond truthfully to the relevant questions. The second assumption is that a guilty suspect will show higher levels of arousal to relevant questions compared to control questions. Although they'll respond deceptively to both types of questions, the relevant questions pose a more immediate threat to the suspect, and so they should elicit a stronger physiological response. As an aside, if the guilty suspect doesn't respond deceptively, then they've essentially confessed to the crime and we don't need to do a polygraph. To work out whether the suspect is innocent or not, the polygraph tester will look at the output recorded by the machine and then rate the differences in physiological responses to each of the question types. The differences are generally rated from -3 to +3. If on the basis of these ratings the suspect fails the test, they're pressured into a confession in a post-test interview. The second type of polygraph test is called the guilty knowledge test. This test aims to determine whether the suspect has knowledge about a particular crime that they do not want to reveal. For example, imagine the following scenario. A suspect has killed a person with a knife, they deny this during an interview, and then the polygraph examiner shows the suspect a series of knives, including the one used in the killing. For each knife, the examiner asks the suspect if he or she recognises it. Now, both an innocent and a guilty suspect will deny recognising the knife. The difference, however, is that the guilty suspect should show a heightened physiological response when shown the correct knife that was actually used in the crime. For the innocent suspect, all the knives should produce the same reaction because none of them have been seen before. Now obviously you can only use this version of the test if you have a piece of evidence, like a knife, that you can show the suspect and that hasn't been reported in the media. So how reliable are these tests? Well, despite some of the claims made by companies that offer polygraph services, the accuracy rate varies quite a bit. As you can see, while the accuracy rates seem to be a bit better than those for relying on non-verbal behaviour, they don't always perform at the levels that some people think, and they're quite a way off being 100% accurate. You can also see that the accuracy depends on whether you're trying to detect a truth or detect a lie. And for the crucial role of lie detection, accuracy can fall to levels not much higher than chance for the guilty knowledge test. When we look at polygraph accuracy across a large number of studies, we can see that there are about 78% of guilty suspects are classified accurately as being guilty. Almost 70% of innocent suspects are classified correctly as being innocent. Now, although these figures seem reasonably reassuring, just over 15% of innocent people are incorrectly classified as being guilty, and about 10% of guilty people are incorrectly classified as being innocent. Now, while some people might be willing to accept these accuracy rates, even though they are less than perfect, the issue is actually a bit more complicated than that. To get a full understanding of how reliable polygraphs are, we need to take into account the underlying base rate of deception when we use a polygraph, and this can actually be pretty difficult to know. So let's take the accuracy percentages we just talked about and apply those to a context in which the rate of deception is 50%, which might be typical in an experiment testing the validity of a polygraph. So imagine we have 500 liars and 500 truth tellers. When we do this, we can generate a table like the one you see now. This table combines the percentages of correctly and incorrectly identified liars and truth tellers and applies that to our 500 liars and 500 truth tellers. Now the numbers on the right just outside of the table tell us how many people are accused of being liars next to the positive row and how many people were identified as truth tellers next to the negative row. So there were 471 people identified as liars and 398 people identified as truth tellers. We can work out the chance that a person identified as a liar is actually a liar, and the chance that a person who is identified as a truth teller is actually a truth teller. So for each of the 471 people accused of lying on the basis of this test, there's an 83.44% chance that he or she is actually lying. And for each of the 398 people certified as being honest, there's an 87.69% chance that he or she is actually honest. Now, that doesn't look so bad. Still not perfect, but perfection's difficult to achieve. What happens when the base rate of deception decreases, however? Is it really the case that half the people who might take a polygraph are being deceptive? Let's rework those numbers, but this time assume a base rate for deception of 5%. So we have 50 lies in a group of 1,000 people. When we do this, we can see that the numbers actually change quite a bit. So let's work out the chance that a person who fails the test is actually lying. There are now 186 people accused of lying, but for each one of these, there's only a 20.97% chance that he or she is actually lying, because the test now identifies a large number of people as liars, even though they are actually truth tellers. For each of the 667 people classified as being honest, there's a 99.25% chance that he or she is actually honest. This looks more reassuring. So, in sum, although the polygraph can discriminate between liars and truth tellers, the number of false positives is rather high. False positives are those people identified by the test as liars, but who are actually telling the truth. So perhaps the best use of the polygraph is to identify when people are telling a truth rather than when they're telling a lie. In other words, use the test to rule people out of an investigation rather than rule them in as a suspect. So why don't polygraphs perform better? What are the problems with polygraphs? Well, one of the problems we've already discussed are potentially low base rates of deception. It's difficult to get an accurate estimate of these base rates in real life, as we've already said. Some people are also relatively emotionally non-reactive, and so they don't produce the physiological responses we expect to see when lying. It's also possible that innocent people might react pretty strongly to questions about whether they committed a crime or not, because they worry that nobody will believe that they're innocent. The polygraph examiner also has to convince the suspect that the polygraph is a flawless detector of lies for it to be most effective and most accurate. This necessarily involves lying to the suspect, which is not allowed in many jurisdictions. A problem specific to the guilty knowledge test is that a suspect may well admit to having guilty knowledge, but deny that they were the person who committed the crime. For example, it's possible that they know which knife was used because the actual criminal told them or showed it to them. The test can't differentiate between this type of knowledge and guilty knowledge due to actually committing the crime. Also, as we mentioned before, the guilty knowledge test can only be used when there are sufficient specific details about a crime known to the investigators, and these details haven't been released to the public. More generally, polygraphs suffer from a lack of standardisation. The scoring is subjective and the questions will differ from test to test. Another problem is that suspects may employ countermeasures in an attempt to defeat the polygraph. For example, they might bite their tongue or press their toes on the floor. According to research by Hontz and colleagues in 1994, these types of countermeasures can actually reduce the detection of lies by 50%. Another reason why we should be cautious about claims made about the accuracy of polygraphs is that it's very difficult to actually test the accuracy of polygraphs, mainly for two reasons. In the lab, studies don't involve the same severity of consequences for participants. It simply would not be ethical to put research participants in the same context that a real suspect experiences. And while field studies might seem like a solution to this, unfortunately we can never know for certain who's lying once we test the polygraph outside of a lab setting. So what about other machines that might help us detect lies? Well, some researchers, such as Kozel and colleagues, suggest that activity in particular brain regions, such as the right anterior cingulate gyrus, might be a better test of whether someone is lying or not. One way we can measure activity in the brain is by using fMRI. fMRI stands for Functional Magnetic Resonance Imaging, and it is a machine that is used to image how brain activation changes over time in response to different stimuli. It does this by using a very large magnet to detect changes in blood oxygenation in the brain, and it's assumed that increases in blood oxygenation are associated with increased brain activity in those regions. Langelben and colleagues suggest that fMRI has high deception classification accuracy, and they suggest that such a test could be feasible for practical use. However, one issue is that fMRI machines are very expensive to purchase and run and not particularly portable, and they also require highly trained staff to run them and interpret the scans. It's also not clear whether the courts would accept evidence based on an fMRI scan. So the research leaves us with a somewhat difficult conclusion. Nonverbal behaviour is not a great marker of deception, and polygraphs are not fantastically reliable either. It's worth knowing this, however, because it's important that people, such as investigators and jurors, don't rely on unreliable indicators of deception and truth when making important decisions. And perhaps it's best if people focus on the strength of the evidence when trying to decide if someone is being deceptive.